What is that you are seeing in this question 27 is that in a steady two-dimensional flow of incompressible fluid, streamlines are as shown in the figure. It is a streamline found out at point A or point B. Which of the 2 points pressure is higher? I said at B, at B, streamlines are crowded. At A, streamlines are wider. Obviously, velocity at B is greater than velocity at A. So therefore, pressure at A is greater than pressure at B. Done. Right. Next, a ball is projected in still air with respect to the ball. The streamline appears as shown. Obviously, at 2, streamlines are crowded. Than at 1. So therefore, V2 is greater, 1 minute, V2 is greater than V1. So therefore, P2 is less than P1. Okay, na? Got the point? So, at which point is the pressure 1 or 2 larger? I just answered. Now, this is, if the ball is spinning in clockwise direction, for this, what you will answer? Same situation. If it is clockwise, crowded over here, because this will drag some lines here. At this point, it is not, it is less crowded. So at V2 is greater than V1 or V top is greater than V bottom. ఇదే కదా మ్యాగ్నస్ ఎఫెక్ట్. మ్యాగ్నస్ ఎఫెక్ట్. Right. Next question, question number 33. You can see in this situation, a horizontal glass tube is filled with mercury. The tube has 3 different cross sections. Can you see 3 different cross sections here? A1, A2, A3. A1 is equal to 18 centimeters. A1 is equal to A2 is equal to A3 given. Piston is pushed so as to throw out mercury at a constant speed of V is equal to 6 meters per second at the other end of the tube. Here you tell me whatever you want. A1 V1 is equal to A2 V2 is equal to A3 V3. Equation of continuity. Now from this I can say A3 V3 is equal to A2 V2. 9 into V is equal to 8 into V2. Equation 1. V2 is equal to 9 by 8 times V. Andaga? Just please confirm. Am I right or not? A3 is this. A2 is this. Similarly, A3 V3 is equal to A1 V1. So therefore, V1 is equal to A3 9, A1 18. Correct? Times V3 V. 9 by 18 times V. Yes or no? So this is a 9 by 18 times V is 6. 3 meter per second. This 9 by 8 times 6. Maha aithe 4 and 3. 27 by 4 meter per second. Right? Done. So first I have determined the velocities at the respective points. Do you have any doubt in this? Right. Next, what is that they are asking is, now I'll try to compare the situations at two different points. Why? Because I know that I am applying some force F at this point. Find the force needed to push the piston, assuming the frictional force between the piston and the tube ball is F. That is the pressure at this point. You have given pressure at A2 also, which is rho GH. Because at this point, rho GH. Why? Above it is vacuum. Correct? If there is, it is open to air, I would have written P0 plus rho GH. Right. Plus half rho V2 square. They have given every value here. Rho they have given, V1 we know, V2 we know. They have given everything here. So finally, F minus 40 by A1. 18 times 10 power minus 4 plus half rho 13.6 into 10 power 3 V1 square 9 is equal to 13.6 into 10 power 3 into 10 into H plus half 13 point ఇక్కడ పోయేది ఏది వాటర్ అంతే కదా horizontal tube is filled with the tube has 3 different okay everything is water. No, everything is mercury, sorry. Right, good. ఇది పరిస్థితి. That's all. Are just solve this here. Just solve this. Everything is available to H also they have given. They given H, if I'm not mistaken. No, they haven't given. మరి ఇంకే ఆప్షన్స్ ఉన్నాయి? ఇంకో ఆప్షన్ ఉంది నాకు. ఏ ఆప్షన్స్ ఉన్నాయి? ఇంకో ఆప్షన్ ఉంది. దీని ఇలా కూడా రాసుకోవచ్చు. ఇక్కడికి వచ్చేసేటప్పటికి వీఆర్ రైటింగ్ ఒక్క నిమిషం అండి. I have another option. No, I'll explain. I have best option here. I'll exercise that. Instead of working like this, I'll compare at these 2 points. At these 2 points. That is best for me. P naught plus F minus 40 by A1 plus a half rho V1 square is P naught plus half rho V3 square. That is the best option. Every data is available to you. Now you use that, you will get F as given answer. Can someone tell me what is the answer that you will get? Nearly 371.2. Trust me. You want height, right? You have two options. One, you compare these 2 points. Rho GH plus half rho V2 square is equal to P naught plus half rho V3 square. Antega, you just compare it like this. You will get H. You will get a H as 26 centimeters. Please convey. Do you have any doubt in the application part of this? మీరు ఏం చేస్తారంటే ఇప్పుడు ఇది సోషల్ స్టడీస్ అలా వింటారు ఇప్పుడు ఏదో వేశారు అలా వేయాలి ఈ ఈక్వేషన్ చేయాలి అయిపోయింది. ఎందుకు వస్తుంది మీకు చెప్పండి. ఎగ్జామ్లో నాకు అసలు రావటం అసలు స్ట్రైక్. ఎందుకు స్ట్రైక్ అవుతుందంటే, ఎందుకు స్ట్రైక్ కాదు ఎగ్జామ్లో అంటే ఇక్కడ నువ్వు కన్విన్స్ కాలా, బై హార్ట్ చేసేసావు స్టెప్ని. ఇదే క్వశ్చన్ ఇలానే ఇస్తారని ఏముంది? ఇక్కడ నేను వేసింది రెండు ఈక్వేషన్స్. ఈక్వేషన్ ఆఫ్ కంటిన్యూటీ, బెర్నౌలీస్ ఈక్వేషన్. బెర్నౌలీస్ ఈక్వేషన్ ఎట్ 1 and 2. ఇక్కడ బెర్నౌలీస్ ఈక్వేషన్ ఎట్ 2 and 3. రైట్? Got the point? Any student having doubt on this? అడుగు. ఎక్కడ 1 and 3? 1 and 3. Correct. Good. Right. We'll move on to the next question. In a two-dimensional steady flow, velocity of fluid particle at x comma y is given by so and so, and u naught b being constant, the equation of streamlines. What is the definition of streamline force? The tangent drawn at any point gives the direction of tangent at any point gives you the direction of velocity at that point. What is Vx? U naught plus Bx. What is Vy? Minus By. Slope dy by dx, you know already. What is the formula for slope? Dy by dx. This is nothing but Vy by Vx. This is nothing but minus By by U naught plus Bx. This can further be written as కదా. ఇక్కడ అంతేగా ఇంటిగ్రేషన్. ఇది తెలుసా తెలీదా? అరే ఏంటి అలా చూస్తారా? 1/a plus bx ఇంటిగ్రేషన్ నేను వేసింది. అంటే ఇక్కడ ఒక విషయం ఏంటంటే మనకి ఇనీషియల్ కండిషన్స్ తెలియదు కాబట్టి ఒక పని చేయొచ్చు. సిన్స్ వీ డోంట్ నో ఇనీషియల్ కండిషన్స్, ఇండిఫినిట్ ఇంటిగ్రేషన్ చేయొచ్చు మీరు. ఇండిఫినిట్ ఇంటిగ్రేషన్. ఫస్ట్ పాయింట్ ఏంటంటే యూ కెన్ క్యాన్సిల్ -1/b on both the sides. So what you will get is log e. అవును ఇక్కడ మైనస్ ఎందుకు, ఇది ప్లస్ ఏగా, అరే యార్ ఇది ప్లస్ ఏగా. log e u naught plus bx plus log e y is a constant. Please confirm me whether you understood this step or not. Right? Follow అయినట్టేనా? ఎవరు చెప్పారు ఈక్వల్ కాదని? అవును, అంతా బీతో మల్టిప్లై చేసేసాను, ఏమవుతుంది? log e u naught plus bx is equal to minus a log e y plus some constant. b into constant is another constant. దాన్ని అవతలకి తీసుకొచ్చాను, లెఫ్ట్ సైడ్. log m plus log n. హౌ యూ విల్ రైట్ mn? ఫైనల్గా నాకేం వచ్చిందంటే u naught plus bx times y is a constant. అంటే దాని అర్థం ఏంటి? ఈ స్ట్రీమ్ లైన్స్ ఎట్లా ఉంటాయి? అరే ఒక ఎక్స్ ఇంటూ వై అయితే ఒకలా ఉండేది, ఇది ఎలా ఉంటాయి స్ట్రీమ్ లైన్స్? స్ట్రీమ్ లైన్స్ అలా ఉంటాయి. రెక్టాంగులర్ హైపర్బోలా టైపే, బట్ నాట్ ఎగ్జాక్ట్లీ లైక్ దట్. ఎక్స్ ఇంటూ వై కాన్స్టెంట్ లా కాకుండా కొంచెం యువతలకు వచ్చి ఉంటాయి. ఓకేనా? క్లియరా? షూరా? రైట్. నైట్. నెక్స్ట్ మంచి క్వశ్చన్ ఇది, అడగచ్చు. ఐడెంటిఫై చేయమని అడగచ్చు మిమ్మల్ని. దే ఆస్క్ యు టు ఐడెంటిఫై దిస్. నెక్స్ట్ 62. ఎనీ డౌట్ ఫర్దర్ ప్లీజ్ ఆస్క్ మీ. అదేంటి తల్లి, ఎక్స్ ఇంటూ వై కాన్స్టెంట్ గ్రాఫ్ కదా మామూలు. ఇప్పుడు ఓకే, నీ డౌట్ నేను చెప్తాను చూడు. వై ఈజ్ ఈక్వల్ టు 0 పెడితే ఏం చెప్పలేవు కదా. సో సమ్ వై ఈజ్ ఈక్వల్ టు 0 పెట్టేయలేం కాబట్టి ఎక్స్ ఈజ్ ఈక్వల్ టు యూ నాట్ ఇంటూ వై ప్లస్ బిఎక్స్వై గ్రాఫ్ గీయాలి. ఎట్లా ఉంటుంది అది? యూ నాట్ ఇంటూ వై, లేదా ఇంకోలా రాసుకోవచ్చు, వై ఈజ్ సమ్ కాన్స్టెంట్ బై యూ నాట్ ప్లస్ బిఎక్స్ గ్రాఫ్ కావాలి నీకు. ఈ గ్రాఫ్ ఎట్లా ఉంటుంది? మామూలుగా వై ఇంటూ ఎక్స్ గ్రాఫ్ అయితే రెక్టాంగులర్ హైపర్బోలా లాగా వచ్చేది, ఇట్లా కరెక్ట్గా సిమెట్రిక్గా ఉంటుంది. బట్ యూ నాట్ ప్లస్ బిఎక్స్ కదా గ్రాఫ్, కొద్దిగా రైట్ సైడ్ షిఫ్ట్ చేయాలి. యూ నాట్ మైనస్ బిఎక్స్ అయితే లెఫ్ట్ సైడ్కి షిఫ్ట్ చేయాలి. యూ నాట్ 0 అయ్యి ఉంటే ఇలా ఉండేది గ్రాఫ్. ప్రతి ఎక్స్కి యూ నాట్ యాడ్ చేసుకుంటూ పోవాలి. అంటే అప్పుడు గ్రాఫ్ ఏమవుతుంది, ఈ పార్ట్ ఏమవుతుంది, ఈ యొక్క పార్ట్ రైట్ షిఫ్ట్ కావాల్సి వస్తుంది. ఇది x into y కాన్స్టెంట్ గ్రాఫ్. ఈ a plus x into y కాన్స్టెంట్ గ్రాఫ్. ఇది x into some y plus b కాన్స్టెంట్ గ్రాఫ్. అట్లా ఉంటాయి. అర్థమవుతుందా నేను చెప్పింది? రైట్. 62. Cylindrical container having radius r has a perforated holes through the walls. There are large number of uniformly spread small holes on the vertical wall occupying a fraction of 0.02 of the entire area of the wall. To maintain the water level at a height h in the container, water is being fed at a constant rate. Find Q. అరే ఇప్పుడు డ్రమ్ ప్రిన్సిపల్ ఇది. డ్రమ్ ప్రిన్సిపల్ అంటే అర్థం ఏంటి? పడే రేట్ ఈజ్ సేమ్ యాజ్ ఎగ్జిటింగ్ రేట్. అప్పుడే కదా హైట్ కాన్స్టెంట్ ఉండేది. డ్రమ్లో నీళ్లు పోస్తున్నారు, కింద ట్యాప్ తిప్పేశారు. డ్రమ్ వాటర్ ఈజ్ ఎంటరింగ్ ఇన్ టు ద డ్రమ్, వాటర్ ఈజ్ ఎ లీవింగ్ డ్రమ్. Rate at which water is entering and rate at which water is leaving, if same, then the height remains constant. Right or not? So what you need to do here is, now for example, you take a hole at a depth y randomly. Okay. Now, the velocity of F flux here is root 2gy. Agreed? Total area ఏమయ్యేది? 2 pi r. What is that? Height h కాదు, L అనుకోండి. Eta is equal to 0.02 of the entire area of the wall. So therefore, what is area? Area of a hole divided by L. So therefore, area of hole, small holes on the vertical wall occupying a fraction Any doubt till this point? Right. So what is the expression for a radius smaller ichadu? Malla confusion raakunda. Smaller ichadu kada. Right? So volume rate of flow. Eta times 2 pi r dy, because that's a dy. Into velocity of a flux. Doubted? Any doubt? Eta times 2 pi r dy. రెండు సార్లు dy రాసా, ఎవడు చూడాల. Into root 2gy. Do the integration 0 to h. 0 to h. So do the integration part. You will get 2 pi r eta, which is totally common out, root 2g common out, root y dy 0 to h. Any doubts on this? Root ante y to the power of 3 by 2 by 3 by 2. అంతేగా ఇంటిగ్రేషన్. సో నీకు ఇది ఏమొస్తుందంటే 4/3 πr eta root 2g. All this is a constant, and finally you will get h to the power of 3 by 2. మిమ్మల్ని ఏమని అడుగుతారంటే వాల్యూమ్ రేట్ ఆఫ్ ఫ్లో త్రూ ద హోల్స్ ఈస్ ఏ ఫంక్షన్ ఆఫ్ హెచ్ అయితే ఏమవుతుంది, h to the power of 3 by 2. In fact, this is q. Any doubts? Sir, wrong cut, sir. This is the rate at which water is leaking out through the holes. Okay, no. This is the same rate at which water is entering. Rate at which water entering in. So, if the rate at which water entering in, the rate at which water going out, Q dash is equal to Q implies H constant. That is the fundamental principle in solving this question. Please tell me, do you have any doubt in this? Sure, everyone in the class. Right. You can see another question, 64th question. Water tank has a small hole in its wall and a tapered nozzle has been fitted into the hole. The diameter of the nozzle at the exit is d0 1 centimeter. Right? The height of the water in the tank about the central line of the nozzle is 2 meters. Calculate the discharge rate. Right. Another nozzle. Mundu దీని సంగతి చూద్దాం. ఇప్పుడు very clear I can say that this comes under A much greater than small a. ఈ కేసు అదే కదా వచ్చేది. So clearly velocity of efflux is root 2gh. మిమ్మల్ని ఏమని అడుగుతున్నారు, రేట్ Q is equal to AV pi d0 square by 4 times root 2gh. ఇచ్చిన డేటా సబ్స్టిట్యూట్ చేసుకోండి, మీకు ఆన్సర్ వస్తుంది. పై ఇంటూ d0 ఎంత ఇచ్చాడు, 1 సెంటీమీటర్ ఇచ్చాడు, 10⁻⁻⁴/4, 2 into 10 into height 2. ఇదంతా సాల్వ్ చేస్తే మీకు నియర్లీ 4.96 into 10⁻⁻⁴ మీటర్ క్యూబ్ పర్ సెకండ్. లాస్ట్ ఇయర్ చేశాం కదా ఇవన్నీ, మీ దగ్గర నోట్సే ఉంది ఏకంగా ఫుల్. రైట్, ఫస్ట్ పార్ట్ ఈస్ డన్. Another nozzle which is diverging outward is fitted smoothly to the first nozzle. The pressure at the neck of the two nozzles where the diameter is d0 drops to, and akkada pressure is expressed in terms of height of water. Calculate the exit diameter d of the nozzle. Bernoulli's equation వేయాలి మనం, అంతే కదా. ఇప్పుడు ఈ పార్ట్ ఇక్కడ ఉంది, బెర్నౌలీస్ ఈక్వేషన్ వేయాలి. ఇక్కడి నుంచి ఇలా వచ్చింది ఒక స్ట్రీమ్ లైన్. ఏం వేస్తారండి మీరు, మీరు P1 ప్లస్ half rho V1 square plus rho GH is equal to P2 plus half rho V2 square తీసుకోండి. ఇక్కడ అట్మాస్ఫియరిక్ ప్రెషర్ 10 meters ఉంది. అసలు ఈ పాయింట్ దగ్గర V1 అన్నారు మీరు, అసలు అక్కడ వెలాసిటీ 0. హైట్ ఇచ్చారు మీరు, ఎంత ఇచ్చారు, హైట్ ఎంత ఇచ్చారు మీరు? అరే 10 meters అంటే అలా వేసేయకూడదు. రో ఇంటూ జీ ఇంటూ 10, ఇది కూడా అంతే. రో ఇంటూ 10 ఇంటూ హైట్ ఎంత ఇచ్చావమ్మా? 2. ప్రెషర్ మీరే ఇచ్చారు బాయ్స్ అండ్ గర్ల్స్, మీరే ఇచ్చారు. 2.5 meters ఆఫ్ వాటర్ నాజిల్ దగ్గర. రో ఇంటూ జీ ఇంటూ 2.5 ప్లస్ హాఫ్ ఇంటూ రో ఇంటూ V2 స్క్వేర్. అరే అన్నీ తెలుసు కదా, V2 కట్టలేరా మీరు? ఎస్ ఆర్ నో? కెన్ యూ ఫైండ్ V2? జస్ట్ సాల్వ్. దిస్ ఈజ్ 12. అరే ఇదేమంతా 12, రోజీ 12, ఇది పోతే 9.5. సో ఫైనల్గా V2 ఏమొస్తుందంటే √2 ఇంటూ రో పోయింది జీ ఇంటూ 9.5 చేస్తే నియర్లీ 13 పాయింట్ ఎంత 7 meter/second. అయిపోయింది క్వశ్చన్. ఇంకేం కావాలి? క్యాలిక్యులేట్ ద ఎగ్జాక్ట్ డయామీటర్. శుభ్రంగా కడతాను నేను. ఎట్లా కడతాను? నౌ దిస్ ఈజ్ 2 and this is 3. ఈక్వేషన్ ఆఫ్ కంటిన్యూటీ ఎట్ 2 and 3 అంటే πd0² V2 is equal to πd²4 V3. ఈక్వేషన్ 2. ఇంకో విషయం, ఇక్కడ బెర్నౌలీస్ ఈక్వేషన్ వేయచ్చు. మళ్ళీ మీరు అంటే 1 and 2 బెర్నౌలీస్ ఈక్వేషన్ వేయచ్చు. అప్పుడు ఏమొస్తుంది? అది P1 ప్లస్ హాఫ్ రో V1² ప్లస్ రో GH ఈజ్ ఈక్వల్ టు, మళ్ళీ ఇక్కడ కూడా P0 వేసేస్తాను, మనకు తెలుసు కాబట్టి, హాఫ్ రో V3². మీరు ఇది సాల్వ్ చేస్తే యూ విల్ గెట్ V3. సబ్స్టిట్యూట్ దట్ హియర్, యూ విల్ గెట్. ఎనీ డౌట్స్ బాయ్స్ అండ్ గర్ల్స్? దీస్ ఆర్ వెరీ స్టాండర్డ్ మోడల్స్. యూ ఆర్ ఎక్స్పెక్టెడ్ టు డూ దీస్ క్వశ్చన్స్ ఇన్ ద ఎగ్జామ్. Any doubts? You will go wrong only in the calculation part. Right. Almost. Right. There are 2 large identical open tanks as shown in the figure. In tank 1, there is a hole, small hole of cross-sectional area A at its base. Tank 2 has a similar hole to which a pipe of height h has been connected as shown. The internal cross-sectional area of the pipe can be considered to be equal to A. Point 1 marked in both figures is a point just below the opening in the tank, point 2. Okay, right? First question solve cheyandi. Find the speed of flow at point 2 in both the figures. Please try to understand, when you are doing this problem, case, we will call this as case 1 and we will call this as case 2. At case 1, in case of case 1, the issue is P0 plus rho GH is equal to P0 plus half rho V1². So V1 is √2 GH. Also, you said the area of cross section is A here, right? And one more important point is, see, if you see at 1 and 2, mostly pressure is the same. So obviously, V2 is V1² plus 2GH. V2 is 2G capital H plus 2G small h. I have successfully done the first part of the question. Any doubt? Please ask. Any doubt, please ask. The problem with the second case is 1 to 2 velocity of flow must be the same because it is of same area of cross section. So therefore, at case 2, P naught plus, you are comparing these 2 points now. అంతేగా అంతే కదమ్మా అరే ఈ పాయింట్ మనం స్ట్రీమ్ లైన్ తీసుకునేది రైట్. Find the ratio of speed of flow at point 1 in first figure to that in the second figure. See, please try to understand first case at 1 by second case at 1 is equal to root 2 GH by root 2 H plus H. I am not cheating you. Remember, at velocity at 2 is the same as velocity at 1 in case 2. Because same area of according to equation of continuity, if it is the same area of cross section, they should have same velocity. Otherwise, equation of continuity go wrong. Right. Find the difference in pressure at point 1 in both the figures. My goodness, I will assume P1 is the pressure there, half rho V1 square velocity there. Hello, P1 half rho V1 square. Half rho V2 square. Second case. So in the second case, P1 is equal to in first case, P1 is equal to simply P naught, open to A. Am I correct? Say yes or no for this. So you are asking me about P1 minus P1 dash. This is simply rho GH. So what is the answer for that? Simply rho GH. Please confirm me whether I've done correct or not. Next question. Are we clear? Just please confirm. Everyone in the class? Everyone in the class? Right. Question number 70. The figure shows a non-viscous, incompressible and steady flow in front of a sphere AB. You can see that A to B is a horizontal streamline. It is known that the fluid velocity along the streamline flow is given by V naught is equal to 1 plus R cube by X cube. V naught is the velocity of flow on the streamline. X tends to infinite. It is given that the pressure at X tends to minus infinite is P naught and density of the liquid is 0. Can you see 2 points here? A point here called P And remember, this is the point where x coordinate is a negative. Do you have any doubt? Right. Now, at A and P, if we apply Bernoulli's equation, P naught plus half rho V naught square is equal to, because you said that A pressure is in P naught. I'll take A as infinite point. Whereas pressure at P plus half rho V naught square times 1 plus R cube by X cube whole square. Please confirm, have you understood this step or not? నేను ఎక్కడెక్కడ కంపేర్ చేశాను, ఈ పాయింట్ దగ్గర, ఈ పాయింట్ దగ్గర. Compared at these 2 points. Obviously, pressure at P is nothing but P naught plus half rho V naught square common 1 minus 1 plus R cube by X cube whole square. That's what you asked me. And you want me to plot the graph. Now, y-axis I am taking pressure at a point P. This is negative x-axis side. I don't have need to work to in the positive y direction, positive x direction, because all the coordinates here are negative. Okay. So now at some infinite point, you set the pressure is P naught. Actually, the nature of this graph grows like this. Exactly, approximately the nature of the graph goes like this. Remember, when x becomes equal to r, when x becomes equal to r, this will become 1 minus 1. The entire thing will become 0. Ante kada? When x is equal to r, at x is equal to r, what happens? So the entire term will vanish. So P at P becomes P naught plus half rho V naught square. And at some point, pressure might be 0 also. Right. You will face somewhere here minus r. Any doubts? Boys and girls? Doubts? Please ask me. It's a very simple question. Only thing that you need to find is the equation. That's all. Any doubts? Right. ఇది చేస్తాను, ఫస్ట్ ఇచ్చేసేస్తాను. ఈ 2 క్వశ్చన్స్ చేస్తే మోస్ట్లీ అయిపోతుంది నాకు. Please see this question, everyone. A free jet of an ideal fluid strikes the wedge kept on a smooth horizontal surface as shown in the figure. Out of the total flow, a portion is deflected 37 degrees and remained is not deflected. It's a very important observation. Now, till here, okay, right, no issues. The horizontal wet components of the field needs to hold the wedge stationary or fine. Now, see, I am assuming that the cross-sectional area of this portion as A1, right? See, what is the initial momentum of this system? Initial momentum. Let this be initial momentum be Pi bar. This can be written as actually dm, what is the initial velocity? V. dmv I cap, for example. By the way, what is the dm by dt? Rho AV. Correct? Therefore, this can be written as rho AV square dt I cap. Please confirm whether you understood this step or not. Immediately after final momentum. Of course, magnitude is the same. But the issue is direction change is there. In this direction, it is going. So a unit vector in that direction will be cos 37. This is the direction. Cos 37 I cap minus sin 37 j cap. Agreed? What is change in momentum? P final minus P initial. Rho A V square dt times cos 37 means 4 by 5 minus 1 I cap minus 3 by 5 j cap. Rho A V square dt can be written as L dp bar by dt is the force. And that is rho A V square times minus 2 by 5 I cap minus 3 by 5 j cap. Now you got the point. Fx by Fy is simply 2 by 5 by 3 by 5. That is, just please confirm. అమ్మ మళ్ళీ చెప్పరా ఇది -1/5. Thank you. -1/5. 1/5 by 3/5. They are asking what is n. N is a 3. Boys and girls, any doubts? So I have done this simple problem with a simple basic Newton laws of motion condition. Right. May I proceed further? May I shift on to the next question? Liquid flows in XY plane such that the velocity of the fluid particle located at XY do not change with area. Okay, fine. Same concept we have done just now. Slope dy by dx is Vy by Vx minus y by x. dy by y is minus dx by x. Log ey is log ex plus some constant. Log exy is a constant. X into y is a constant. It is rectangular hyperbola. Okay. Fortunately, only one option that you have rectangular hyperbola there. Right. Any doubts? Next. Next. Same question, only small difference. Stream of fluid of cross-sectional area A, mass density rho and velocity V is diverted by a smooth plate. Same question. Previously wedge arrangement, now some curved arrangement. What is the force required to hold the plate in the place? Same approach. Initial momentum you see AV square rho dt. Final momentum you see AV square rho dt cos theta I cap sin theta j cap. What you are now going to do is the change in momentum part. So the change in momentum delta P bar is AV square rho dt cos theta minus 1 I cap sin theta j cap. So delta P bar by delta T is AV square rho cos theta minus 1 I cap plus sin theta j cap. So the x component of the force is known, y component of the force is known, and fx square plus fy square gives you the resultant force. Boys and girls, any doubt? Any doubt? Same question I have done. But the issue is in the second case, what is the force if the plate is given a constant velocity u in the direction of v? Here, there is a small change. Remember, you have written v square. Now you should write v relative square. I am repeating my observation. In the place of v, you should write v relative. So f of x, f of y, f of x, f of y, and f is fx square plus fy square. 2 rho a v minus u square sine theta by 2. Any doubt? Boys and girls, any doubt? I'm asking again. I have done the same question. Only difference is in the place of V, I have written V relative square. Right. So what else you want in this? What is the force? I done the force. That's all. Fy. What is the optimum speed U of the plate for the generation of maximum power by the action of the fluid on the plate? Very good question. See, Fy is not, see, area velocity is like this. You have two components. One is Fx, the other is Fy, if I am not mistaken. అంతే కదా. So for power, this has nothing to do. Why? Product is 0. So you require this product only. Fx into U. Fx term already we know rho A V minus U square 1 minus cos theta into U. See, this is a product of two things. It's a function of U here, function of U here. So now you require that function T as a function of U. You want a maximized condition. Mathematics says dP by du is 0. D by du times V minus U whole square into U is 0. Now I've done the differentiation part. See that? Done the differentiation part. Boys and girls. I got finally V as a 3U or U is V by 3. There are two options are there. One is U is V. Why we will get another option? Maximum power or minimum power already in the maximum power. So therefore, U is equal to V by 3 is one option. Here, ఇప్పుడు ఇది చేసేటప్పుడు you will have two options. One is this. The other is V minus U is equal to 0. రెండు చేయొచ్చు కదండి. While solving, you will get two equations. One is this equation, the other is V is equal to U. So two possibilities are there. One, yet U is equal to V by 3, power will be maximum. Yet U is equal to V also, power is maximum. Please confirm, have you understood this question or not? I am telling you, out of all the questions which I have done in fluid dynamics, is the most difficult one. You do it 2 times, the moment when you are back to home. Next and last. Make it. ఇది రాలేదా మీకు? అసైన్మెంట్ లో క్వశ్చన్ ఇది. This is a question from assignment. చేయండి ఫాస్ట్ గా. Only 2 questions left actually. So Vy will be root 3 Vx. Please try to understand. Comes out with velocity V. Follow the flow like this. Strikes normally. If it strikes normally, 30 degrees, 30 degrees. So therefore, Vx by Vy tan 31 by root 3. This is one relation I have. Right. Calculate H is what they're asking. Right? No issues. For example, if this is H, what is going to be this part? If this is H, no, 1 minute. It is striking normally here, right? Okay. From this, I can find time also. Half ZT square is equal to root 3 Vx. How to write Vx? H minus H. Now I got a T term also right now. The T term is 2 by G 6G capital H minus small h, or simply you can write wholesale everything denominator 24 by G times H minus H. That is a time. The time taken by the element to strike that. Right. Now, what else the information I can use? Time is what I have. What else the information I can use? You know this distance also. I am doing mistake and no one, very unfortunate that no one is identifying this. How it can be half GT square? Now you are telling us, sir. I'll be get disturbed by this certain messages, meeting, thereafter, all that. బుర్ర పాడవుతుంది ఏదో మీటింగ్ ఉంటుంది దానికి వర్క్ ఏం ప్రిపేర్ చేసుకొని అయిపోయింది షిఫ్ట్ అయిపోయింది అన్నది క్లాస్ నుంచి అక్కడికి రైట్ నౌ యూ హ్యావ్ టైం దిస్ ఈజ్ హాఫ్ ZT square and this is range, so you can know this part also because you know this angle. Right, hold on. So this distance is x and this distance is h2. H2 is x tan 30. X is nothing but Vxt by root 3. Right. Vx is nothing. Vx is nothing but minus small h by root 3. T is nothing but by G. G cancel 2 times. By finally I am getting it as 2 times capital H minus small h. H2 2 times capital H minus small h. H1 half ZT square. What is half GT square? Half Z 6 times capital H minus small h by G. 3. This is 3 times capital H minus small h. H1 plus H2 is H. Yes or no? Capital H is nothing but 10. Don't forget that. H1 plus H2. 3 capital H minus small h. 2 capital H minus small h. 5 capital H minus small h is H. 5h is 6 small h. Therefore, h is 5 by 6 times 10, 50 by 6. 6 eights, 48, 20, 6 threes, 18, 8.33 meters. 90% of the question comes under projectiles. Only one case comes under fluid dynamics. What is that? What is that? Vx is root 2g capital H minus small h. Well, Torricelli's theorem. Applying Torricelli's theorem. Rest all is kinematics. సార్ నేను కైనమాటిక్స్ వినలా, నేను చేయగలిగేది ఏముంటుంది చెప్పండి. ఇప్పుడు నేను అప్పుడు జాయిన్ అవ్వాలా, ఏం చేయలేను నేను. ఐ కెనాట్ డూ ఎనీథింగ్, రైట్? సో one more problem is left actually. This is the problem. Now everyone start working on this problem. Start now immediately. ఇంకా 2 మోడల్స్ చేయాల్సింది ఉంది. Everyone try this. In a machine, a fluid from a compressor which is at high pressure is allowed to pass through a nozzle. This is the nozzle. Cross section of the nozzle is shown in the figure. The nozzle contains of 2 sections, radii R1 and R2 respectively. Nozzle is fixed to a stand with the help of a clamp. No issues. It won't move. The fluid from the compressor is at a pressure of n times the atmospheric pressure. Right. Rate of flow కావాలి. ఎక్కడెక్కడ అప్లై చేస్తారు చెప్పండి మీరు. One thing is very clear. If the fluid from the compressor is at a pressure of n times the atmospheric pressure, right? What should be the volume rate so that the pressure of the fluid at end B reduces to half of its value at end A? అంటే ఎక్కడ కంపేర్ చేయమంటాడంటే here and here, 2 points. Here and here, right? Let this be 1 and let this be 2. Bernoulli's equation at 1 and 2. Here the pressure is NP naught plus half rho. Remember, equation of continuity says agreed. You said in beat reduce it to half. You said it is reduce it to half. Right. Now using these two equations, we can write one and two, we can write NP naught plus rho by 2 Q square by pi R1 square whole square. NP naught by 2 plus rho by 2 Q square by pi R2 square whole square. By solve this, by solving which you will get NP naught by rho. అంతేగా అది ఇటు తీసుకొని వస్తారు. NP naught by rho is equal to Q square by pi square R to the power of 4 minus Q square by pi square R1 power 4. So you will get Q as pi R1 square R2 square under root P naught by rho times R1 power 4 minus R2 power. Any doubt? Boys and girls, very, very, very good question. Do not compromise on this. Simple question actually. Only thing is that you need to understand that. What is that they are expecting? If the entire system is kept in gravity-free space and the net force on the nozzle due to fluid flow is F, then determine the minimum radial pressure that should be applied on the clamp so that nozzle remains in place. Coefficient of friction between clamp and nozzle is mu. Can you please tell me what is exactly happening over here? So you are applying a pressure force PA in this direction. And what stops this is the friction leftwards. This is on the system externally. This is on the system, again is the friction. Done. So therefore, P into A is mu into N, normal reaction. So therefore, what do you want? P is, N is nothing but that's all I have done the question. In terms of R1 లో అడుగుతున్నట్టున్నాడు. R1 డిటర్మిన్ అంటే మీరు కట్టాల్సినది మిమ్మల్ని అడిగినది ఏమిటి? ఒక నిమిషం. ఇంకేమైనా బి అనేది ఏమైనా రైట్, ఇక్కడ ఈ ఏరియా కావాలి నాకు. ఇది నార్మల్ ఫోర్స్ అవుతుంది అక్కడ. అయిపోయింది. దట్స్ వాట్ యు వాంట్. మిమ్మల్ని ఏం అడిగారో దాన్ని చూసుకొని చేసుకోండి. దట్ ఈస్ అ ఫోర్స్. అంటే మీరు if a small any doubt in B, please ask me. నేను కొంచెం బాగా చెప్పే ప్రయత్నం చేస్తాను. రికార్డ్ అవుతుందా ఫస్ట్? ఇలా బెల్ట్ ఉంది కదండి. ఎవ్రీ పాయింట్ దగ్గర ప్రెషర్ ఫోర్స్ ఉంటుందిగా. ఇదే నార్మల్ ఫోర్స్ అక్కడ. సో నార్మల్ ఫోర్స్ ఏమవుతుంది? ప్రెషర్ టైమ్స్ 2πr1 p. That is the pressing force. So mu n is mu times you want p. That's all. Any doubts? If a small hole is punctured anywhere on the thinner part of the nozzle close to end B, okay, what should be the volume rate of flow so that it does not gush out? Very simple. P naught N P naught is the pressure difference. So therefore, N P naught plus half rho V1 square is equal to P naught plus half rho V2 square. That's the relation. ఇంకేం నేను చేసేది అయిపోయింది. NP naught minus P naught is half rho V2 square Q square by pi R2 square whole square minus Q square by pi R1 square whole square. దీని నుంచి Q తీసుకోండి. Q వచ్చేసి pi R1 square R2 square under root Any doubts, boys and girls? Sure. Right or not? ఇంకా మనం ఏం డిస్కస్ చేయని ఒక్క నిమిషం. Two questions from siphon working. With this, almost all models are done. Almost. Balance is your assignment itself. Now start working on this question, everyone. A tube of uniform cross section is used to right. See, what is the first condition for working of siphon? Do you remember? I have given conditions are like this, H2. Rho G H1 plus H2 must be less than or equal to P naught for the working condition of siphon. Do you remember this, boys and girls? And one more important condition is that the velocity of your siphon, I don't know why you are looking at my face. I've given this theory. And one more, what is the velocity of efflux at B? Root 2G H2, independent of H1. These are the two principles, working principles of siphon. So velocity, so A is wrong, B is correct. If H2 is 3, maximum value of H1 for which, see, please try to understand. Now you take up this H1 plus H2 less than or equal to 10 power 5 by 10 power 4 less than or equal to 10. If H1, H2 is 3 meter, H1 less than or equal to 7 meter. C is correct. If H1 is equal to H2 is equal to 3 meter, right, what happens? The pressure of the water in the highest, okay, no issues. This is allowed actually. H1 plus H2 less than 10 is allowed. Okay, fine. What you will write is P naught plus P naught is equal to P at C plus half rho V square plus rho G H1. Do you remember this relation? Now, one thing is very clear. V is always root 2 G H2. There is no change in that. So, therefore, P naught is PC plus half rho 2G H2 plus rho G H1, which implies PC is P naught minus rho G H1 plus H2. By a P naught is 10 to the power of 5, 10 power 4 times 6. 0.4 into 10 to the power of 5 Pascal. Right. Please confirm whether you understood this or not. When siphon is given, only two conditions that should strike in your mind is two things. One, rho G H1 plus H2 less than or equal to P naught. VB is equal to root 2G H2. These are the two working principles. Okay. Next question. Siphon has a uniform, see, so long uniform speed throughout the tube is the same. So long it is uniform, speed throughout is the same. Make it fast. Very simple. Velocity of the flow through the pipe is V is root 2G H2. Root 2 into 10 into 3.6. This will become 36 twos, 6 root 2 meter per second. So option A is correct. If the cross section is given, rate of flow is AV. Area of cross section pi r square, 8 square by pi into 10 power minus 4 into 6 root 2. By this is a 64, 64, 6. 64, 6. Diameter is this. So, by 4 kuda untundi. This is a diameter, not radius. By 4 kuda iyali. అప్పుడు ఏమవుతుంది 8 8 64 64 by 4 16 16.6. Boys, any doubt? Okay, when A is correct, C is wrong. Pressure at A, just now we have done. P at A is P naught minus rho G H1 plus H2. Just now we have done this. And they're all repeated. 10 power 4 minus 10 power 4 times 1.8 plus 3.6. 5.4. This is nothing but 0.46 times 10 power 5 Newton per meter square. Any doubts? Boys? Clear? Sure? Right. So with this, almost, just please see, I've done all the questions. All the questions, 29 pages content you have. I have done most of the questions. I'll post these notes right now. Complete notes 2025. I'm just ending this.